This meeting is being recorded.
For problem 8 from chapter 18, we're asked to consider whether or not these products shown in A through D here could be formed doing a direct Friedel-Crafts alkylation, or whether or not we'd be able to do an acylation followed by a Clemmensen reduction. So when we're considering whether or not a Friedel-Crafts alkylation would be a viable method, we have to be on the lookout for carbocation intermediates that could do rearrangement. So for A, we know that we have our benzene ring, and the type of alkyl halide that would be required to form this specific product would look like this. So this type of carbocation intermediate that would form would be likely to do a rearrangement to form a tertiary carbocation that would look something like this. So in order to form our product in A, due to this methyl shift that would occur, or a methide shift, we would have to do an acylation followed by that Clemmensen reduction. So for part B here, we're asked to do a similar analysis. Now the alkyl halide, I'll draw that down here, that would be necessary, would look something like this. And we know that after reaction with aluminum chloride, this would also be likely to produce a, or to perform a hydride shift now to form a tertiary carbocation intermediate like so. So in, again, our first example, we had a methide shift that would occur. Here, we would see, rather a hydride shift like so. So again, a more stable carbocation would occur, or would be formed with this tertiary carbocation. So we would again have to do the acylation followed by the Clemmensen reduction. So let's take a look at C. The alkyl halide there would look something like this. That will be needed to generate our product shown in C. Once again, this could undergo a hydride shift. So this hydrogen here would be shifted to, or rather, I'm sorry, this hydrogen here would be shifted over here to form a more stable secondary carbocation intermediate. So we would again have to do the acylation followed by reduction for part C's product. Last year with part D, we can do a direct alkylation. In this scenario here, we can do that direct Friedel-Crafts alkylation because we do not generate a carbocation intermediate that could be stabilized through rearrangement.